All right, so 13C, we're looking about separable differential equations. So we've almost kind of touched on this a few times when we've had equations that have both x's and y's in them, and we have to try to integrate. Okay, so that's what this is all about. We're going to have equations where there's some part where there may be some, what we call a function of x. And if I can get, in my derivative, if I can get all of the x parts in one spot and then all of the y parts next to it, then that is a separable differential equation. Because what we're going to do is I'm going to take, I'll write it down at the top here, the y dash, I will split that to be dy over dx, right? Then that's equal to f of x times the g of x. There's my x components and my y components. What I want to do is I want to move all of my x components to be together and all of my y components together. And that's including the dx and the dy. So what I would do is I would leave my dy on the left-hand side, and I'm going to divide the g of y over to the other side. So it would become 1 over g of y. And the f of x, that's over on the right-hand side, I times the d of x over to the other side. And there I have all of my y parts on the left and all of my x parts on the right. And then I'm going to be able to integrate both sides. When I do that, I'll be integrating the left side with regards to y and the right side with regards to x, because that was a dy and that was a dx. All right, okay, so that is wasting our time. Okay, so all of that first part there is going through what I've just done by splitting them up. So you can see down here, there's the 1 over g of y dy, f of x dx on the other side. So constant solutions, always check whether any constant function, so you might have no y's in the equation, which means you might have a 1 there and you're just integrating a 1 kind of thing. So always check whether there are any constant functions in the differential equation. These are horizontal isoclines consisting of horizontal line elements, and they are usually horizontal asymptotes of nearby solution curves. Dealing with absolute values, because we are going to come across them, because if we're integrating things that dy, for example, that was on the bottom, they integrate to logarithms, don't they? Okay, so we are going to have some absolute values popping up. When interpreting absolute value signs in a solution, acknowledge that e to the power of c is always positive, c being a constant, and it doesn't matter if the constant is positive or negative, e to any power is always going to be a positive value. Right? Modify the solution when removing the absolute value signs, and then modify the solution again if any constant function is a solution. It's much easier to see this in action, so let's do it. So question 1, I want to solve y dash equals negative 2x e to the power of y. So you can see in there this negative 2x, that would be a function of x, right? That's the function of x part. And the e to the y, that's my function of y. You wouldn't have to write this because it's our first one. I'm just trying to show you that they're my two different parts of my equation. So I'm going to change it to be a dy over dx equals the minus 2x e to the y. And I'm going to try to get all the y's over on the left, which means I'm going to have to divide by e to the y across to the left-hand side. I'm going to get all of my x's over on the right-hand side, which means I have negative 2x, and I times the dx from the denominator across the other side. Is that part making sense? Cool, because once we get to there, we now are going to do the integrating part. Now, we're just going to integrate both sides, because if we do the same thing to both sides, it will still be equal. So I'm going to integrate, I'm going to change that 1 over e to the y to be e to the negative y, because that's a much nicer thing to integrate, and integrate minus 2x dx. Okay, Integrating practice. How do you integrate e to the negative y? Yes. So technically it is e to the minus y over minus 1, but that minus 1 is just going to go to the front, but I'll fix that up on the next line. How do we integrate minus 2x? That was meant to be the easy one.
Oh, I'm just right there.
Yes. So slower steps, I'll do add 1 to the power, divide by the power, and the 2's will cancel out as Ben's giving me the simplified answers, which is great. Now, when you integrate things, because there's no values on my integral signs, this is an indefinite integral, right? When I integrate the y side, there would be a constant that could potentially be there. And there would also be a constant when I integrate those x's. But overall, we could just combine those two things to be one constant, right? So you don't have to do a constant on both sides, just one constant that I'm going to put on the end of my right-hand side here. So let's just tidy it up a little bit. So that's going to be minus e to the minus y. Minus, the 2's will cancel out to be minus x squared plus c. Okay, now when we can, we like to try and get our equation in y equals, right? That's how we usually like our equations. Y is equal to something in terms of x. To do that, I'm going to have to get rid of the exponential part, but before I do that, how about the minus sign? Let's get rid of the minus first. So it'd be e to the negative x, dividing the minus sign through would be x squared, and technically it would be a minus c.
I just did plus c.
It's a constant is a constant, yeah. And I will change that as well. Yeah. Okay, cool. As long as you're familiar with that, I'm okay with that too. All right, so how do we then change to get that y by itself? A sliding base. So we'll have negative y equals log base e, or ln, of x squared plus c. Okay, and then just move the minus sign across. Okay, and we've managed to get our equation. Now that is a family of curves because we still have that constant in there, but we are given some information in part B. It says find the solution curve that is going to go through 0, 0. So if I sub that in, I'll be able to find the more specific equation for that particular one. So let's sub in the 0, 0. We get 0 equals minus ln of 0 squared plus c, or just c. So I can just write that minus ln of c. And because that's equal to 0, let's do a sliding base going the other way, right? C would be equal to
1.
Yes, because it's e to the power of 0, and e to the power of 0 is equal to 1.
Negative 1.
No, positive 1. The minus sign I could just get rid of from here because, oops, I deleted my whole L there, because it's divide the minus sign across. So I just go, let's just get rid of that minus sign. Don't need it because dividing by minus, I still get that.
Isn't it funny when you cross out a minus sign, just signs?
Correct.
Yeah, that's good.
So what is our equation? It is y equals negative log base e, or ln, of x squared plus 1, and we've found that particular equation. All right, let's try it again. Question 2. Solve the differential equation for y dash equals x over y. So like before, let's try and separate our x and our y parts. So I have dy over dx equals x over y, times the y across to the left, so I'd have y times dy, and times the dx across to the right, so x dx. Then we are going to integrate both sides, and you could just write the integral straight on that last line, but because we're new to this, I'll write the extra line. Okay, integrating y, you get, yep, y squared over 2 equals integrating x. is x squared over 2. And don't forget to add on your constant.
Does the constant always go over the x side?
Yeah. Okay. We wouldn't have to, but that's just the most standard place to see it, yes. Okay, what should I do to that equation? Maybe let's times through by 2 to get rid of all of those fractions. However, because it is an x squared, y squared equation, what kind of curve is this? It's a circle. If you went all the way down to the square root, you could potentially lose some solutions by doing that. It is the whole circle. 7. So we're timesing by 2, so that means that we have a 2 times the constant here, but
So we
no. So what I'm about to do, let me just finish it off, is I was going to say instead we could just say y squared is equal to x squared plus, pick a different letter. Okay, it is still just a constant. So it really doesn't matter whether it's 2c or it's d or whatever it is, though that thing at the end there is just a constant. And to write it down correctly, you would still write here next to it that you're saying that d is equal to 2c. This is, we're only timesing by 2 here. We're going to be doing these with plus or minus exponential kind of things happening as well. So it's just a good habit to get into at this stage to be able to replace a more complicated looking constant with a single letter. Okay, all right. Find the solution passing through the point 4, 5. So we sub it in. We're going to sub in that y is 5, so 5 squared equals 4 squared plus d. 5 squared is 25. I'm going to subtract the 4 squared across, so subtract 16 is equal to d, which means d is equal to 9. That means that I now have the equation of my graph. It's a y squared equals x squared plus 9. It's not actually a circle because it's be a minus x squared if I move that across, wouldn't it? Not a plus. Anyway, yes, making sense so far?
Yes.
All right, let's do it again. Lots and lots of practice, same kind of thing. Question 3, solve y dash, so we're going to change that to be dy over dx equals minus xy squared. Move the y squared across to the left, so dividing will be 1 over y squared dy, and times in the dx over to the other side. It'd be minus x dx. Okay, integrate both sides. Instead of having 1 over y squared, what would be a better way to write that? Yes. Okay, integrating time. Integrating the negative y to the negative 2. We add 1 to the power, divide by the power, so it'd be negative 1 on the bottom, or just negative out the front. And then the x, add 1 to the power, divide by the power, and then plus the c. Okay, get rid of the minus sign. So we'll have y to the negative 1 equals positive x squared over 2, and let's just leave it as a plus c. And there we have it.
Why is it positive x?
Because I divided through by the minus sign.
I got negative 1, 2. I divided. Oh, you divide by the new power.
Yes, it's by the new power.
Okay.
Yeah?
Does anybody have any things?
Yeah, you could. Yeah. If we wanted to, yes, we could keep going. So that is 1 over y. I'm going to get a common denominator here first so I can flip it. So it would be x squared plus 2c over 2. And again, you could change the 2c to be a different constant. But why? Just so I can get the y by itself?
Oh, so the
Yeah, now I'm going to take the reciprocal of everything. So that will be Oh, okay. Oh, yeah, all right. Yeah, yeah. I actually stopped here at this line. I stopped there. Yeah, you could, because it's just a constant and reciprocal of the constant. Still the same. All right, so maybe I'll just stop back where I stopped. Let's get rid of that other part. Let's just stop there. Keep it simple.
Can you just make it the opposite of the equation? Make the y on top.
No.
Make like the other side of the equation to the power of -1. That would flip the
It's not. Yes.
okay, so, and that
Yeah.
would just get rid of the -1 to the top.
Yeah, it would. Find the particular solution given that y of 1 is equal to a half. Okay, so we're subbing it in and we get half to the power of -1, since I'm just keeping my yellow equation there, is equal to x squared, which is just 1 squared over 2 plus c. It's 1 squared. So I'm subbing into the yellow equation. So x is 1. Do I need to go back? So we're subbing into the y to the -1. So the y value is a half. So that's why it's half to the -1. The x value, though, that I'm subbing in is a 1, which means it's 1 squared, which is just 1 over 2. Too much talking?
No, you just wrote a square.
Oh, I did. It should be a -1. That was the part you were telling me. It was the wrong number. It should be a -1. Because it was y to the power of -1. I'm using my yellow equation. Sorry, I wrote the square because I think I was looking at the x squared when I did
Does
it.
that mean c equals?
Yes, it does. Or isn't it -3/2? Let's have a look. So we've got, let's invert it. So the -1 just means you turn the fraction upside down and you get 2 is equal to half plus x. All right, yep, no, you're right. So it is minus the half. So it is 1.5 or 3/2. Which means that we want to put that back into our equation, which was y to the -1 equals x squared over 2 plus 3/2. Now, because we haven't inverted, this one would be a very easy one to actually invert to get the y equals without worrying anymore about constants and things. So if I write that down as 1 over y, push the common fraction together, to get the y equals, I turn it upside down. So 2 over x squared plus 3. To get the y by itself instead of being y to the -1.
Did you plus not plus 2?
The x squared over 2 plus 3/2 has a common denominator, so I've just pushed those two things together
Oh yeah, okay.
and then inverted both sides. All right, do that whole thing again with the information that y of 2 equals 0. That means y is equal to 0 and the x is equal to 2. So we will get, well, we have a problem, I think, here. We have 0 to the power of -1 equals 2 squared over 2 plus c. We have a problem. What's the problem with that? What does that 0 to the -1 actually mean? 1 over 0. Undefined. So it means this is impossible and you actually can't, there is no solution at this point. So this is impossible.
Oh yeah. Let's be taking you can't have 0 at the bottom of the equation, can you? So that's why it's fifth place.
Yes. I was about to get to that. Very good. However,
Why is it possible?
y equals 0 does actually satisfy the equation if you were to look back at the original differential equation. So it does satisfy the y of 2 equals 0 and the differential equation.
Is it impossible for 0 can't be the bottom fraction?
Yes.
Okay.
So we can't find the equation, but the point itself does actually satisfy the differential equation. All right, move on. Question 4.
Just 1 second.
Yep.
Y equals 2, 0, and the
Differential equation.
DE satisfies.
DE's differential equation.
So it is. So it
is a required solution.
So.
There's an absolute value inside the log and you get
Are you saying
Yeah.
that the differential equation, that's the first equation that we got, works when y?
Question 4, solve the differential equation y dash. So let's change it to be dy over dx equals, and separate our y values and our x values. So we'll have 1 over 1 take away y equals x dx. Oops, I forgot my dy. Okay, is the separating part okay with everybody? And now we get to the integrating part. And 1 over 1 take away y is going to integrate to a logarithm. Now, to make sure that you have a log, actually I should have done something else beforehand because I've made this a little bit nasty, haven't I? With that minus sign, because I need a minus sign on the top. When you integrate a log, the derivative of the bottom needs to be on the top.
The derivative.
So,
Where's at the top though?
what's the derivative of y?
You need a minus sign.
I need a minus sign on top.
You just put minus sign.
Yeah, that's what I did last time. Will that make it easy? Should we go back and do it that way? Should work both ways. That's how I did it last time. Okay, so let's keep going this way then. You could, that's what Ben was just saying, and what I was about to backtrack and maybe do it that way, was if I'd factorized the minus out from this line, then it would have made my logarithm nicer. So I could have made that a negative x of y take away 1, and then my log would be nicer. But anyway, let's keep going on the track that we're on. When I integrate, I get negative out the front, and it becomes log of the absolute value of 1 take away y. Okay, that is equal to, integrate the x, and we get x squared over 2 plus our c. Okay, first of all, the minus sign. Let's move it away.
Oh, what the heck?
How about I just use my red pen here? I'm going to cross out the minus on that side and move it across to that side. Is that all right with everybody? Saves me a line of rewriting. Okay, then to get that out of log form, I have to do a sliding base. So it's going to be the absolute value of 1 take away y equals e to the power of the negative x squared over 2 plus c. Yeah? Now, fun times. That looks a bit messy with the two things in the top of that exponential. What if we split that up to be e to the negative x squared over 2 times by e to the c. Okay, because remember, I'm just reverse the multiplication index law. Instead of, if those powers are added, I can split it to be 2 of the bases times together with those powers. Now that means that e to the c is still just a constant, right? So I'm going to be able to change that. But before I do, one more thing. The absolute value signs around the 1 minus y. I can get rid of those. To get rid of the absolute value signs, it means that you need to move a plus or minus to the other side. But the plus or minuses are really just something else I could consider to be part of my constant, right? If I took the plus or minus e to the c and I just made that into whatever my constant is going to be, it makes it much more simplified. That's right. Correct. So what I'm going to do is I'm going to change that. I'm going to use an a this time. I'm going to do a e to the negative x squared over 2. And I'm going to explain over here that a is equal to e to the power of c, where a is positive or negative. Okay, maybe that's too much explaining, but anyway. Or maybe plus, okay, I'll rewrite it. Too much explain. Let's make it just plus or minus. There you go, shorter. Plus or minus e to the c. Sorry? Well, yeah. I mean, you'd have done most of the work at that point, and it's purely for the reason that they prefer to have a y equals equation most of the time.
Yeah.
But even then, sometimes I see in the questions that they give, or the ones that they do in the book, they don't always go to the y equals equation, but for these exponential ones, they do. So we're going to keep doing it. So let's just get our final answer. We want y by itself. I would get negative y is equal to ae to the negative x squared over 2 minus 1, and then get the y by itself. You could do this in less steps, but try not to rush you guys since you're first time going through this type of thing. So let's just go plus 1. Do I need to put the minus in front of that a? No, because again, it's just part of that constant thing. So there it is, my equation. Find a particular solution passing through the origin. So it's time to sub in some things. So origin, we're subbing in 0, 0. So I get 0 for the y equals ae. The 0 squared over 2, that whole power is just 0, plus 1. So e to the 0 is also 1. So a is equal to negative 1. Was that too quick? No, we're good. All right. So my equation is y equals, if a is negative 1, then I have negative e to the x squared, negative x squared over 2 plus 1. Same thing again with the point 1, 1. Sub 1, 1. So y equals 1, ae to the negative 1 squared is, 1 over 2, so negative a half plus 1. So if I subtract the 1 over to the other side, I have ae to the negative half equals 0. Then if you divide the e to the negative half, you're really just getting a equals 0. Because e to the negative half is just a number, divided across the other side, still 0. What does that mean for my equation? It means that whole first term is just 0, and we're getting the equation y is equal to 1. Okay, different types of curves, or a line. Okay. Last page. Solve the differential equation. Y dash equals xy. So dy over dx equals xy. Separating my variables, I will have 1 over y dy equals x times dx. Then I'm going to integrate both sides. What is the integral of 1 over y?
0. Oh no, ln of something.
Ln of the absolute value of y. Integrating the x, you will get x squared over 2 and add on the constant. So this is very similar to the last question now. To get the y by itself, I'm going to do a sliding base. So I'll have absolute value of y equals e to the power of x squared over 2 plus c. Then I am going to do two things. I'm going to split that power to be x squared over 2 times e to the c, splitting the power into the two different terms. And the second thing I'm going to do is get rid of the absolute value signs, which means we get the plus or minus coming across. We would get y equals plus or minus e to the power of x squared over 2 times e to the c. We then want to simplify all the constants that are in there, and let's use a again. I'm going to call that a e to the x squared over 2 because I take all the constants out. So I'm saying where a is equal to the plus or minus e to the c. Easier the second time around? Okay, so now we just have to find the solutions given this information. Find the solution curve. Sub in the point, x is 2, y is 3, and we would get 3 equals ae to the half, or whichever way you want to write it, 2 squared over 2. But altogether, that becomes e to the power of 2. Just simplify it down. What does a equal? 3 on e squared, or maybe 3e to the negative 2. It's up to you. And put that back into your equation. So that means that, yeah, because I'm dividing e squared across the other side, and when you divide it, it would either need to sit on the bottom. I'll do an extra step for you.
Oh, no.
I could either sit it on the bottom like that, or if I bring it out like this. The reason I'm bringing it out is because I'm actually going to be able to simplify it in my solution curve.
It's alright.
With the basis. Yep. So putting it back into my y equals equation from the end of part A, you get y equals, a was 3e to the negative 2, and you're timesing that by e to the x squared over 2. Because you have those two bases of e, keep the 3 out the front, keep your base of e, and add the powers together, which becomes x squared over 2 minus 2. Yeah? Sometimes it's not the differential equations part that's the
It's so hard to
tricky
write.
part. It's
It's so
doing the right indices, laws, and
It's so hard to write that thing, that x squared to so small, so I just did the little upwards arrow thing.
oh, okay.
Is I don't.
All right, and part 2, we're subbing in that x is 3, y is 0. So we get 0 equals ae to the power of 3 squared over 2. But because it's 0, doesn't even really matter what that exponential part is. You divide the exponential across the other side and you get a equals 0. If a equals 0, what does y equal? Not helpful, Ben. And not funny either. Y would be equal to 0 because that's the whole term is multiplied by a.
Oh, so yeah, so you just multiply.
So if you're putting that back into here, 0 times by that whole
So you
term.
just get rid of the e thing.
Yep. Yeah.